Hello, we're going to dive into question 12, which is the opposite spectrum of the periodic table. That would be our group 7, the halogens. This is also 11 marks. Again, very common. And what they like to test you here are the colors of the halogens as well as the unique chemical reaction, which is the displacement. So let's dive in. Okay. Here, so we start off with MCQ. So with MCQ, we are looking at liquid, group 7, which one exists as a liquid at room temperature and pressure. So I'm going to take a moment to identify all of them first. If you are looking at periodic table, you will see fluorine, chlorine, bromine, and iodine in this manner. The state of which they are found in, the first two are the same, it's gas for both. The one that is in liquid state is bromine, and then followed by iodine, solid state. Of course, you will have one more, which is acetylene, and usually they would sort of just ask you to infer. If iodine exists as solid, then what do you think is the state of acetylene at room temperature and pressure? It would also be the same. So the only unique one that exists as a liquid state is bromine. Next thing, so basically you have your answer here, right? It's in there. Bromine is the only one that exists at room temperature and pressure as a liquid state. It has a really low boiling point. The boiling point for bromine is just 59 degrees Celsius. So it is very close to the room temperature and pressure liquid. Okay, so what are the colors here? The colors for bromine is red brown. Okay, so if you are looking at the bottle of bromine, you would be able to see like this. So bromine liquid, and hopefully it's capped, right? Yeah, because of their toxic fume. So you'll be able to see this like very nice, like this reddish brown fume at the top, okay, because of this low boiling point. So you get this gaseous or vapor of bromine when you have a bottle of it. And then you have fluorine. Fluorine at room temperature and pressure is yellow, it's really pale, and then this is green. And then for iodine, it's dark grey. So again, if I ask you to infer, what do you think is the color of acetylene? It even darker than dark grey, isn't it? Okay, so you can see that as we go down this group, the color intensity actually increases. So I'm going to write this down. Color intensity increases. That means it gets darker and darker as you go down group 7. Okay, now group 7 has very unique color. You need to know the color at room temperature and pressure. Just let me write this down. Room temperature and pressure. And they also have another set of color when you dissolve them in water. So I'm going to use blue, okay, in aqueous solution. So the first two, because they are already so pale, both of them will be colorless in aqueous solution. Then you would have bromine. Bromine is going to be one shade lighter than red brown. It would be orange. And then for iodine, it's going to be brown. Is the for those of you who have like script running before, and the nurse apply this antiseptic solution, you might get this like brownish color on your knee or your elbow, depending on where they apply. It would be iodine. Iodine compound is being used as antiseptics. Okay, so you need to know these two colors. They are popular, and you cannot interchange. Like for example, you cannot use brown for bromine when it's in aqueous solution. You need to use one shade lighter, okay? And the reason why I tell the story of iodine is to just really help you to remember, like, because for human being, we really associate better when there's a story, when there's information, or when we have seen something or experienced something. So if you have experienced like iodine being used as antiseptic or for your wound, then you would have remembered this brown. Also, you would have seen iodine for bio, isn't it? Like when you're doing your starch test, is that right? I think so. Okay, next one, let's go move on. Okay, so what's the color of solid iodine? So it would be dark grey. It won't be brown. Okay, so black is only for acetylene at room temperature and pressure. Purple is when you have iodine in gaseous state. So iodine is really, really interesting. Like iodine, so solid, aqueous, and gas, they have different colors. So gas is this very nice purple, very similar to the color of my pen right now. And then if it's in aqueous, it's brown. If it's solid, it's grey, dark grey. So 3 different colors for iodine. So think of that. Really beautiful, but they are highly toxic. Okay, right. Next, we need to describe a test for chlorine gas. Chlorine gas has a pungent smell, really, really bad smell. But it has this very good features of bleaching. Okay, so if we want to start off with damp blue litmus paper, you need to make sure it's damp. If not, it will not work and it will bleach the litmus paper. Then we have a 2-mark question on isotopes. So we have got chlorine 35 and chlorine 37, and they both exist with different percentages. So to do this 3-mark question, what you need to do here is to appreciate that 71.2% of the time chlorine exists as 35, so that's your first step. And then the next step here is appreciating that chlorine 37 exists with about 28.8% of the time. So multiplying each of the value, and then you add them up together, and then you divide by 100. Now why 100 is because this is percentage composition by mass, so this is by percentage, so you need to divide by 100%. So you will get your answer. So things to take note before you write your final answer. It could be a string of answers, but because the question asks for 1 dp, so please present your answer to 1 dp to get your third and final marks. So sometimes students just write down a string of numbers based on whatever is shown on the calculator, but you need to pause, don't waste marks like that, and ask yourself, what is the question requirement? Is it 1 dp, 2 dp, or whatever it is? Okay, so take note of that. All right, next one. Last question here is a 4-mark question, so I will call this a longer mark question. What we have here is the students given chlorine and also sodium iodide. This is a very easy question in my opinion, because you only have one pair of substance to compare with, and you want to compare the reactivity of chlorine with iodine. Now one thing to take note is I'm going to write diatomic formula. Okay, so just to remind you from the previous question, the group 7 exists as diatomic molecules. Okay, but one thing I want to emphasize here is the reactivity. The reactivity for group 7, the highest reactivity or the most reactive one is actually fluorine. So as you go down the group, the reactivity decreases. So right now we are trying to compare the reactivity of chlorine with iodine, and you can see from here iodine is lower than chlorine, so chlorine is more reactive than iodine. So what do you want to do? So the first step that you want to do in order for you to compare reactivity is to add the chlorine into the sodium iodide solution. So that's step 1, put them together, and then ask yourself what would happen. Now if I were to write out a balance equation for this displacement, this is the chemical reaction here is called displacement, where the more reactive halogen can displace the less reactive one, and in this case we know the more reactive one is chlorine because it's higher in the group. Okay, displacement also can be used for metals, but I'm not going to talk about that now. Okay, so we have chlorine, we add it to sodium iodide, and what's happening here is chlorine can displace the iodine in sodium iodide, isn't it? So what we get here is NaCl, and then iodine exists on its own, it's been displaced. Okay, to balance this equation I need to put a 2 here and 2 here. For those of you who want to extend and challenge yourself to write the state symbols, actually all of them are in equal state. Okay, ideally your state symbol should be written on the same row, but I'm limited space, so I'm just putting it underneath. Okay, so it will turn from, the solution will turn from colorless. Now where is this colorless from? This colorless is actually from NaCl, and then it will turn brown because of the iodine that has been displaced. Now this iodine again is in aqueous form. If I can pause and go up a little bit, can you see that? Just going to use red. Okay, iodine in aqueous solution is brown in color. Okay, so take note. These are really commonly tested questions. Okay, so again, I'm going to pause here and just emphasize this is the hardest to score for a lot of students because they are not able to identify what's the final color. So the final color is based on the halogen that has been displaced. In this case, it's iodine. So to explain, because you need to explain, so why do we see brown? It's because iodine has been displaced. So this is the explain, okay, why we see this color, why we observe this color. And then finally this would show, because you need to compare the reactivity, so you need to have a final conclusion statement. So which halogen is more reactive? It is chlorine is more reactive than iodine. So even if you don't know how to do this question, you should be able to get 1 and 4 marks, isn't that? Okay, by putting the solution together. And if you recall this reactivity of group 7, fluorine being the most reactive, then you would be able to score the 4th one as well. Okay, so this is our 4-mark question. This is a longer mark question, but not the hardest displacement question for halogen. If you want, let me try to find my previous video on halogen. I've got a 6 marks one, and I remember doing that before this year, 2025, May-June iGCSE examination, to remind students what to write, what are the common words that they tend to write wrongly when they are describing a 6 marks displacement reaction for halogen. So I might put that link up here, and if you again have any question, feel free to DM me. If not, like, subscribe and for my YouTube video. Alright, there you go.